This will be ACT Prep Plane Geometry. We're going to do triangles, perimeter, parallel lines, polygons, interior angles, similar triangles. We'll just look at some of these topics. I've got 3 questions for you. What I would do is try to answer it myself. So once you see the question, hit pause, and then I'll step you through the problem and see if you got it right. So in the figure below, shows quadrilateral ABCD. What is the measure of angle C? Go ahead and hit stop, and then I'll show you what to do. Okay, so what I would do with this is, first off, you add up the 3 angles. And those would be, 69, so 69 plus 95 plus 135. You add those up and you get 299. Well, to find the missing angle of a quadrilateral, I know that it's 360. A quick proof of that would be if you split this in half into 2 triangles. The sum of the interiors of this triangle are 180. The sum of the interior angles of this triangle are 180. So together they make 360 degrees. And so we know that you could just take 360 minus 299 and you get 61. So B is what the correct answer is. So hopefully that's just kind of a general one that you see on the ACT once in a while. Next question. In the figure below, triangle ABC and triangle DEF are similar triangles with the given side lengths in yards. What is the perimeter in yards of triangle DEF? So in this one, if you're not paying attention to the word perimeter, if you tried to just skim it and quickly answered A, you'd be incorrect because they wanted perimeter. And so, because you're in kind of a hurry, this is a time test, you only have a minute to do it. So you have to look at a little deeper into this than that. And you notice that this is, you got 5 and 5 and 10 for side lengths. So this is an isosceles triangle. That means this one has to be an isosceles triangle, so B has to be 4 if you quickly did that. And so 8 plus 4 plus 4 is 16. So that's the answer to it. Now, if you didn't know that length, you would have to, if you didn't know that about isosceles triangles, you'd have to set up a proportion. So the scalar factor, if you want big triangle to little triangle, would be 5 to 4 equals 5 to B. And if you cross multiplied, so that I went 5 to 4 equals 5 to B, so you can set up a proportion and solve it. So if you're not paying attention, if you're in too big of a hurry, 5B equals 20, and so B equals 4. And so you know that length is 4. And then perimeter, of course, is when you add up all the side lengths. So 8 plus 4 plus 4 is 16. So that's a couple ways to solve that one. And then the third one is this particular one. It says in the diagram, EB is parallel to DC. Find the measure of angle A. So go ahead and see if you can do that quickly. And so in this case, how I would do this is these two are parallel. If this is, and we're trying to find angle A, which is up here, and since these are parallel, these angles 70 are called corresponding. So that is 70. 120 and this angle are supplementary, or a linear pair, and so we know that is 60 degrees. Okay, we also know, now if you just look at the top triangle, right here, triangles, the interior angles of a triangle are 180 degrees, so 70 plus 60 is 130. That's if you add the 70 plus the 60. And so if you take 180 minus 130, you get 50 degrees left over for angle A. So it's 50 degrees. And again, you have to go through that pretty quickly so that you can get through the problem fast and move on to the next one. They don't give you much time on the ACT. Hope this helps, and I'll see you next time.